And yeah, next we're going to bring in, we're going to do it live. We're going to transition to the next session. And we're going to bring in Amin and Jay to talk about ACK, or the AWS Controllers for Kubernetes project. Welcome. How you doing? All right.
I'm doing great. Thanks.
A little latency there, Jay. A little latency. Yeah, welcome to the stream.
Sorry about that. I should probably share my screens. I have a, let's see here. Sorry. I have some slides. Whoops. Can you all see my slides?
No. No, we can't. And that, like I said, we're doing it live.
Okay, then. Oh, well, that would help if I did that properly. How about now?
If you share it, then we can
yes.
see it. And now you won the internet, basically. There you go.
Hey, thanks, Jesse.
All right.
So, yeah, thanks. So, hi, I'm Jay Pipes. Amin Hilali is also an ACK software developer. And today we're going to give you a little bit of an update on what's been going on in the ACK project or projects over the last 6 months or so. And Amin is going to live demo 3 separate ACK controllers doing their magic and communicating with AWS APIs to manage the lifecycle of AWS resources. So I'm actually really excited about this. I've been excited all day. I've actually been watching the Twitch stream, and I'm in there moderating for a time. So I'm super excited about this. Let me get started. But before we get started, I did want to give a big shout out to all the contributors, the open source contributors, internal to AWS, external to AWS, and all our partners. Thank you so much. I think we're like past 1,600 stars or something on GitHub, which is crazy. Absolutely awesome. We have like over 50 contributors to the various ACK projects. We're collaborating with Crossplane and Red Hat, and we're just super excited for all those contributions. So thank you from the bottom of my heart. I appreciate it. You're what makes ACK ACK. So, all right, ACK in 30 seconds, or maybe 60 seconds, we'll see. So what is ACK all about? Basically, it just allows you to manage AWS resources using the Kubernetes API. So instead of logging into the AWS console or using the AWS CLI to create resources or update a resource, instead you simply do kubecon apply and communicate with the Kubernetes API. And there's a set of ACK service controllers that actually communicate with the AWS service APIs for you and manage the lifecycle of resources in your target accounts. We make heavy use of code generation in ACK. So those of you who kind of saw my previous spiel about ACK at other KubeCons or reInvent, you know that, well, there's only a few of us on the core ACK team that are working on all of these different service controllers in ACK land. So there's really no way that we were going to be able to maintain and manage the construction of hundreds of these ACK service controllers without really relying on code generation quite a bit. So we actually take the AWS service API models and we actually output the full implementation of these service controllers. I'll get to that a little bit more later. One thing that makes us a little bit different than some other approaches, we speak directly to the AWS service APIs. So we actually don't go through CloudFormation. We don't construct a CloudFormation stack and use the CloudFormation API in order to track state of the resources within a stack or anything like that. Instead, we talk directly to S3 and RDS and IAM and EC2. And in that way, we're a little bit different than some of the other solutions out there. One other really important thing to mention, we run on any Kubernetes cluster. So even if you don't choose to use the EKS managed control plane and all that, you can use and install an ACK service controller in any Kubernetes cluster in GKE or Azure or running on Kind locally. It doesn't matter to us. We're just a set of normal pods and deployments that you install into any Kubernetes cluster. And yeah, that's what we're about. Also, we're 100% open source and use an open development model. We have community Zoom meetings every week. All of our stuff is done on GitHub in the github.com, AWS Controllers Kate's organization. And yeah, we're really excited to get feedback and bug reports and all that kind of stuff from you. So, like I mentioned, code generation is something we rely on heavily in ACK. We consume the API model files that are, right now, we take them from the AWS SDK Go repository. There's a set of model definitions within the models APIs directory in that source code repository. But we consume those in a tool called ACK Generate. And the ACK Generate tool outputs a set of generated code. Now, we can output an ACK service controller for a specific service. So for instance, if I use the ACK generate controller command, I can generate the controller for S3 by reading in the S3 API model. We can also, because our code generator is quite flexible, we can actually generate the cross-plane provider AWS resource managers for a particular API. So the ACK generate CLI tool is pretty flexible, takes in these API models and spits out a bunch of Go code that follows either the ACK runtime or the cross-plane provider system. And what is the end user experience that we want? Well, we want this end user experience. We want Alice or Bob or any other Kubernetes user to just be able to do kubectl apply, pass in a YAML manifest. I know that's going to hurt Ellie because he doesn't like YAML, but it's okay. Like ACK is all about the YAML, right? So you're just going to kubectl apply and pipe in a YAML manifest that describes the AWS resource that you want to create or update, and the ACK controller for that particular service, in this case ECR, will take the custom resource that you've applied to Kubernetes and speak to the AWS ECR API to manage the creation and update of your particular repository. So this is the end user experience that we want ACK controllers to provide.
I'm just going to throw out there, Jay. I think that these two projects are completely compatible, right? Because you're gonna create YAML, and he can actually leverage that.
He can synthesize YAML.
So it's amazing. It's amazing. You can actually build really cool pipelines here for in CI. Yeah. So anyway, it's cool.
No, I completely agree, and I was mostly just joshing with Ellie.
Yeah, I know.
Any solution which synthesizes to YAML manifest, which obviously CDK does, it integrates fully with our user experience, which is really just the Kubernetes API. So CDK is all about the Kubernetes API. So it's good synthesis. Okay, one big feature that ACK has is cross-account resource management. So we've had this feature for a while, and it's actually been demoed by Amin a number of times to customers and others. It makes the experience of running ACK controllers a little less painful, put it that way. If you are a customer or a Kubernetes user that has lots of different AWS accounts. Let's say you work at a big company, you've got 100 different application development teams, all working on different microservices. You can use a single installation of an ACK service controller to manage resources for that particular service across all of those 100 AWS accounts. You don't need to install one ACK service controller for S3 in 100 different clusters or locations. Instead, you just have the one ACK service controller, and then you annotate a namespace in Kubernetes. A cluster admin would annotate a namespace with the AWS account ID that all custom resources of a particular kind within that namespace should be managed in that AWS account. So in that way, it cuts down on the number of controllers that you need to install in your target clusters. We also support resource adoption. So let's say you've got some existing resource that you want to ask an ACK service controller to take under its own management. Well, we support this resource adoption functionality. And one thing that makes this special in ACK is that it is an explicit action, right? And when I say it's an explicit action, I mean there is a separate, distinct custom resource definition called adopted resource. And you actually have to create that adopted resource and explicitly tell the ACK service controller, hey, I want you to take this particular resource under management. And this is a little bit different than other solutions that have taken an approach where you sort of like have an annotation on a custom resource that indicates that, hey, this thing already exists or not. We took a slightly different approach that we thought was a little safer and a little more manageable to do this explicit, distinct CRD for adopted resources. Okay, so we've got some news about progress that we've had over the last 6 months. Well, not 6 to 9 months in the ACK project. We've had a lot of changes, right? One of the big ones is we have a new GitHub organization, github.com/AWS-controllers-K8S. We have separated our mono source repo that used to be just called AWS/AWS Controllers K8s into lots of sub repos, a community repo for all our documentation, a repository for the code generator, a repository for the common runtime, a repository for all our test infrastructure. And I think we're up to like 16 or 17 separate service controller source code repositories where each of the individual ACK service controllers now lives. So that was a huge thing where we separated out our mono repo and now have these separate source control repositories. In addition to the separate source control repositories, we're now also publishing separate binaries for each of the service controllers and separate Helm charts in individual ECR public repositories. We've got a brand new Hugo-based documentation site, thanks to Nick Thompson. Yes, it's awesome. I'll show you in a second. We've also got another, thanks to Nick Thompson, generated CRD reference documentation on our doc site. Let me show you a little bit. We've got this new GitHub organization that lists all of our repositories. There's lots of them there. Please come contribute. I will note that the GitHub issues are only enabled on the community repo. So if you have a bug or a feature request or something, please go to that community repo. This is our ECR public AWS Controllers K8s gallery. So you see here we've got 32 separate chart and controller ECR repositories. And this is our new documentation site that Nick helped put together. It's all nice and snazzy and well and lovely formatting. I love it. Anyway, and then we've got this reference documentation for the custom resource definitions that each of our ACK service controllers expose. So here you see the Aurora DB cluster resource and the RDS controller, and you see like the fields that go into the spec. All right, I did mention that we have a lot of ACK service controllers. We, I think, are up to 17 at this point in varying stages. So they kind of keep multiplying. We're onboarding more and more AWS service teams into the ACK ecosystem. And those AWS service teams and engineers on those teams are helping to maintain and own their individual service controllers, which is great. So what do we have in preview right now? We have by the way, we have a preview and a GA maintenance phase. And that really just describes the maintaining teams' confidence in the long-running stability of their particular controller. We've got preview for Amazon MQ, application autoscaling, API Gateway v2, DynamoDB, ECR, EC2. Now EC2, we've got, I think, 4 resource managers now, maybe 5. I think Brian was working on VPC endpoint yesterday. We've got security groups coming and a number of other core EC2 networking concepts, constructs, new resource managers coming out every week for the EC2 controller. Elasticache, KMS, RDS, S3, SageMaker, SNS, and step functions. All of these controllers are in preview right now. I have Elasticache and SageMaker highlighted in green because they are quite close to going generally available. And then we also have 4 controllers that are currently in progress. The EKS controller is going to be very Inception-like. It's kind of like MC Escher as a service. We've got the work started on the IAM controller. That is our #1 most requested controller outside of EC2. So support for declaratively binding IAM roles and policies, that kind of thing. That's going to be awesome with the IAM controller. Lambda, which actually is in progress right now, and Amin is going to be showing you that in progress controller, and it's actually working. So, and then also SQS, we are currently in progress working. So, all that said, we are now going to hand over to Amin to do a demo of an ACK, a set of ACK controllers that are the Lambda, S3, and DynamoDB controllers that are going to be managing the lifecycle of AWS resources in a sample application, a serverless application that Bob is going to communicate to the Kubernetes API to construct all of the pieces of his application. So let's see, I'm going to hand it over to Amin.
Thank you, Fox. Are you able to see my screen?
Maybe a little bit bigger on the font if you could. Comically big is better than too small. That's my motto. Comically big. Love it.
Okay, is this good?
Maybe one more. Yeah, that's good. Thank you.
Okay, perfect. So let's get started. For this demo, I prepared an EKS cluster. And as Jay said, we don't really need an EKS cluster to run ACK controllers. You can run them on Kind, Minikube, bare metal, whatever you're using for Kubernetes. You can spin ACK controllers and use them to deploy your resources. So as Jay said, for this demo, we are deploying 2 Lambda functions, 1 DynamoDB table, and 1 S3 bucket. And before getting started, all the code and the manifests you're going to see today is available on GitHub. We're going to share the link by the end of the presentation. And yeah, let's get started. So this is my repository. I have a directory with some functions, list item Python and put item Python, which is basically putting items on a DynamoDB table and listing them. And I have a resource directory containing the manifest for a DynamoDB table, a Lambda function, and an S3 bucket. Before starting deploying everything, I'm going to show you what the functions look like, just to get an idea of what we are doing here. So for example, put item .p. It's a simple Python function that loads an environment variable called table name and uses the DynamoDB table client to put an item in it. And it's basically using a UID generator to just put random UIDs in the table. For the other one, it's a list items, which is also a Python function, doing the same thing exactly. It's just going to list the items in the table and return them to us. And for this demo, we're going to use ACK to deploy these Lambda functions, the DynamoDB table and the S3 bucket. And at the end, we're going to invoke the Lambda functions and verify that they are working correctly. So before starting to deploy a Lambda function, we're going to need an S3 bucket where we're going to put all the Lambda functions, and then so we can create the Lambda functions using ACK. And for that, we have manifest, for example, for S3 bucket. We have a YAML file, like any Kubernetes manifest starts always with an API version, kind that is a bucket. And here we have a metadata name and a spec name. The metadata name is the Kubernetes name that is used to store an object in etcd or the API server. And the spec name is the name used by the AWS API to create your S3 buckets. So the S3 buckets will have literally this name. For this demo, they have the same name, but they can have totally different names. It's totally OK. So I'm going to start with this. I'm going to apply this manifest, S3 bucket YAML, and we're going to see that in action. So if I do get bucket, like get pods, we're going to see that we have a bucket that got created. Normally, there's a controller that will catch the event and create the S3 bucket for us in the cloud. If I do an AWS S3 LS and I grab ACK demo, I should see a bucket that got created. So we got here a bucket that just got created called ACK demo bucket Kubecon 2021. So our bucket is ready. Now we just have to zip the functions and upload them to the S3 buckets. And to that, I'm going to go to the functions directory, run the zip file, zip command twice. I zip my functions, and now I can do I put object, sorry. I put object for the put item and for the list item zip file. Okay. List item zip file. Okay, so now that our code is on the S3 bucket, we can go and create the Lambda functions. However, what we can do before is create our DynamoDB table before creating the Lambda function. That will not really impact something, but I can show you what a DynamoDB table, for example, manifest looks like. Sources, DynamoDB table. To create a DynamoDB table, like any Kubernetes manifest, you need an API version and a kind. Like S3 bucket, we need a name and a table name. We have one primary key, or let's say hash key, that is an ID. And we have a default provision throughput and a streaming specification, which is not used in this demo, but just for the sake of defining our DynamoDB table. Let's go and apply this. Let's do our DynamoDB table. Should be created. If I do get table, I will see my table here. If I do get table, demo table, or YAML, we can see more in depth what our table looks like. We're gonna see that it's got a status, and the status contains the ARN of the DynamoDB table, the owner account ID, the AWS account that was used to create the demo table. And here at the end, we're going to see the table status that says it's active, which is ready to be used or consumed by the Lambda functions. So everything is OK from our side. We can go ahead and deploy the Lambda functions. So before, let me show you the Lambda functions. We do resource, Lambda functions. Like the other manifests, we have two Lambda functions in here, two Lambda functions resources defined in one YAML file. You're going to see that we have a function name and a code section where we define where can the Lambda function find the code for, or the Lambda API find the code for this function. And we're going to see here, I'm precising the S3 bucket name, the put item.zip, and I have a role arm that I prepared before that, basically giving a DynamoDB read writes to put item, and for list item, I have a DynamoDB read only. I also I'm having a variable environment variable name, table name, demo table, so that the Lambda functions know to which table write and read from. With that said, I can go ahead and directly deploy our Lambda functions. I'll go and click on apply. The functions. So two resources got created. If I do get functions, I'm going to see that I have two functions that just got created behind the scenes. The controller captured that and created them using the AWS API. I can go ahead and do a Lambda. I think it's get function. If I do this, I can see that the state, for example, of my put item function is active, and last update status is successful. So our Lambda function is ready to be invoked and called live. So with this showed, I can directly call a Lambda invoke. I can do here. I'm gonna call put item first. So as I showed in the Lambda function, this function will just generate a UID and put it in the table. So as much as I call this function, we're gonna get more rows in the DynamoDB table. So if I call it twice, we're gonna have 2 rows in the DynamoDB table. And now if I call Lambda invoke for the list, I'm gonna see two elements in the DynamoDB table. So we're gonna see here the items of the DynamoDB table. There is the first ID and the second ID. And yeah, that's it. We have 2 Lambda functions, 1 DynamoDB table, and one S3 bucket fully deployed using ACK.
That is super cool. That's it. Yeah, and you're like, that's
and
it.
live, and the live demo
Yeah.
that didn't mess up.
Yeah,
Well
this is
done.
the
Yeah,
one live.
you've done something right for the demo gods. We had one question during this that I think is really pertinent to the demo, and this sort of reflects a couple of other ones, sort of about state management and over time. So ACK would recreate the S3 bucket if I delete it, right?
If you deleted the S3 bucket via the AWS console, yes, the ACK controller would attempt to recreate that. The tricky, so you can sort of detach a particular resource from ACK management by sort of like detaching or deleting the finalizer in ACK land. So you can kind of work with both, but
the thrust of the question was more, I think, in the positive vibe, where people are thinking sort of toward this declarative config and control loops and reconciliation and GitOps, and this is just a really great fit. Like this is sort of extending that to your cloud resources. Fantastic demo. Thank you. Do you guys have anything left in this session? You just covered so much stuff. Super impressed.
One thing I didn't demo this. I mean, I can demo it if we still have time, but there is also the update and the delete operations. I only create the resources using Kubernetes. But for example, if I go and let's say I modify the DynamoDB table attributes, the controllers will watch that and go and update my DynamoDB table instead of recreating it. And the same for deleting a resource in the API server. The controllers will watch that and delete them. So yeah, the ACK controllers are literally doing any CRUD operation using the API, the AWS API to manage the resources.
Right. That's
and
awesome.
I can answer a couple questions if we've got any time left, but maybe not.
I believe we are just about out of time.
All right. Well, find us on Provider AWS Kubernetes Slack channel and ask all the questions you want. We're happy to answer them. Thank you so much.
Thank you, Jay. Thank you, Amin. And next up, we're going to move from that action-packed session into our hybrid application partner panel hosted by Alan. So stay tuned.